The easiest way to compare skill level among a group is to compete head to head and either use a tournament bracket format or a league table format. The International Rochambeau Tournament is a rock, paper, scissors competition that ranks participants based on match or game results against other participants. The thing is, the competitors are artificial intelligent bots. Sony E. Valdez, Vitruvius John D. Barayuga, and Preciso L. Fernandez created an AI bot to demonstrate their theory of effectiveness against competitors in the first International Rochambeau Tournament. They did not give the bot a name, so we will call it Larry. Larry obtains its knowledge by reading its opponent's played move and storing it for later analysis. These moves are stored in arrays, which will represent the knowledge of the opponent's previous moves and then automatically determines which move the opponent is likely to make and plays the counter. Larry is also flexible and adaptable to change in its opponent's patterns or behaviors. Okay, details. Because the rock, paper, scissors is such a simple game, the possible inputs are rock, paper, scissors, and the possible outputs are the same. As mentioned before, Larry uses an array that represents the history of the opponent's moves. But there's another array to store the most recent sequence of moves. The researchers call it the window. And this window's size is defined before the running of the bot, so let's call it n. For the first move, the researchers chose to always play rock to avoid using the random number generator. After that round, before Larry plays, it takes the last n moves and stores it in a variable called sec, short for sequence. Larry then searches the history for sec, and if the sequence is found, the move that is after the sequence is added to a count of rocks, papers, and scissors. This process is iterated for the entire history to find other occurrences of sec. However, if the sequence isn't found, or the size of n is larger than the history, then the sequence size is decremented and the process is repeated. This is repeated until a sec is found. Now after tallying, Larry chooses the highest tally as the prediction. If there's a tie, a count is done for the options in the tie across the entire history. The option with the highest count is used as the prediction. Well, what if we get another tie? Then Larry uses the random number generator to select among the tied results and produce the prediction. Last thing is for Larry to play the winning move against the prediction.
Where does this bot fall down? Larry does not fare well against bots that do not have patterns. For instance, there's a dummy bot that uses pi to determine its moves, and since pi doesn't have any patterns, there aren't any for Larry to predict. The other thing is that against other history-based bots, Larry loses to the two best, which are ranked 1 and 2. One that uses direct history, and the other, the Iocane bot, which uses complex decision-making. The Iocane bot is so sophisticated that it can detect if a bot has predicted the Iocane algorithm and start to play against itself. And Larry is a bot that tries to predict the Iocane algorithm. Where does this bot strive? Larry does not fall to all of the history-based bots. One of the dummy bots, Beat Frequent Pick, which is Larry's inspiration, it tallies the occurrences of rock, paper, scissors in the past, and the highest tally is a prediction. Beat Frequent Pick gets trapped by Larry trying to predict its moves, thus showing that Larry has evolutionary capabilities since that behavior was not coded. Larry's algorithm easily beats bots that intentionally use patterns in their play, such as Switch-A-Lot bot, which never plays the same move twice, and Godot Rock, which only plays rock.